Let's build a lens with more complex distortion. And this time, we'll also address lens breathing. Lens breathing is the effect where, during a focus shift from a near object to a far one, internal lens elements move, causing a visible change in distortion. Visually, the frame might appear to breathe or subtly warp. The more complex the optical design, the more pronounced this effect becomes. In compositing, this needs to be properly accounted for. If the source footage shows visible breathing distortion from focusing, that distortion must also be reflected in the tracking. To build a matching lens preset, you need to shoot a distortion grid at different focus distances, from the closest focus to infinity. If you're wondering how to shoot such grids correctly, check out this video and this document. We prepared them specifically for this use case. Here we're now working with the results from the captured distortion grids. The sequence camera is no longer needed, so we can delete it. We'll simply create a few reference frames, load the grid plates into them, and continue working from there. To load not just one, but multiple reference frames, without creating each one manually and loading images one by one, we can use the multi-image import function, especially if all the images are located in the same folder. File, import, multiple reference frames. You can do this without the script as well, just by creating multiple reference frames manually. But let's look at another method. Specify the path where the distortion grid images are located. Here's my folder with the grids. These are grids captured at different focus distances. This file is at 1 meter, this one, 2 meters, then 3 meters, 5, 10, 20, 40 meters. There's also 1.4 meters, which is between 1 and 2 to serve as an intermediate step. To import multiple files, we don't need to specify the file name, just the path to the folder. And now we've got as many reference cameras as there were files in that folder. It's best to sort them right away, in order of increasing focus distance. That'll make them easier to work with. I select them, and while holding the middle mouse button, drag them up. Yes, it's not very intuitive, but that's how it works. Hold the middle mouse button. See, this is what lens breathing is all about. The camera stays in place, and the grid doesn't move either. All of these distortions happen only because the focus distance is changing. It clearly shows how serious the tracking and compositing errors can be if you don't account for breathing. Again, the camera and the grid remain completely still. It's only the focus that's being adjusted. What do we do next? Right now, each of these grids, shot at different focus distances, is linked to the same lens, and each one uses the same distortion parameter. That doesn't work for us because the whole point is to get dynamic distortion. So what we need to do is change the focal length type to static for each of these grids. Here, we know that this grid was shot at a focus distance of 1 meter. This one was shot at a focus distance of 1.4 meters. And so on. 2 meters. 3 meters. 5 meters. 10 meters. The unit of measurement here is centimeters, but you can change it in the settings. Options, preferences, focus distance units. That's the one. Let's switch it to meters, since that's what we're using for everything else. 20 meters. And 40 meters. Next, we switch to distortion grid controls mode and apply the grid one by one to each of the distortion reference frames. We can manually adjust the first 3 ourselves. And snap. If something goes completely wrong, you can always click Reset Matrix to reset the grid and start over. There's also a Smart Reset button. It not only resets the grid, but also automatically tries to align it to the existing checkerboard pattern. Here it found the corner, and then we click Snap, and the rest of the grid automatically snaps into place. Using Ctrl plus arrow keys, or through the menu, we add rows, first filling the main visible area of the grid. And once the main area is filled, we start adding rows along the edges, going beyond the frame to cover the entire grid area. We do the same with the remaining grids. We go to the lens parameters. First, we have pixel aspect equals 2 here because it's an anamorphic lens. Second, now we're going to calculate keyframes for each focus distance. So we open the curve graph. This can be done through the curve editor window or by attaching the curve editor through one of the lower interface panels. Curve editor. These are the animation curves for camera and object movement in the scene. We'll get to them in the next lesson. Right now we're interested in the curves related to lens distortion, but in general you can switch between categories here and see which curves are available for editing. We're interested in the focus distance curve. This is what will drive the dynamic distortion. The exact same principle applies when creating dynamic distortion for zoom lenses. It's just that instead of a single parameter, you would animate two. Now let's select the distortion model that matches your lens. In the dynamic distortion parameter, we choose which value will drive the distortion. Right now, the mode is set to static, which means neither the focal length nor the focus distance affects the distortion. It's treated as constant. But in our case, distortion changes depending on the focus distance. So we select the appropriate mode, driven by focus distance only. We're looking at a situation where we specify that distortion parameters will change dynamically, depending on one of the following: focus distance, focal length, or both at the same time. When we do this, manual editing of distortion parameters becomes disabled. They will now update automatically based on the calculations from each of the distortion grids. Next we go to calc distortion. Here we have selected the distortion parameters to be calculated, the reference grid from which they will be read, and the focus distance that corresponds to this grid. Now we run the calculation. And we create a keyframe on the curve for this focus distance, in this case for 1 meter. Let's take a look at what we've got. For the distortion parameters in the lens distortion section, at a focus distance of 1 meter, keyframes have now been created for each of these parameters. That keyframe is still the only one, so we don't yet see any variation or dynamic change. Now we'll calculate more keyframes and start to see how the distortion evolves depending on the focus distance. Let's move on. Go to calc distortion. Select the second grid 1.4 meters and click calculate. We set the keyframes. Let's take a look. Here's how this distortion parameter changes as the focus distance shifts from 1 meter to 1.4 meters. A similar dynamic is observed across the other distortion parameters. They all gradually start changing depending on the focus distance. Alright, let's go ahead and set all the remaining keyframes. We ended up with this kind of curve. And as you can see, each distortion parameter now has its own animation. The next important step is to smooth the curves because right now in some areas the interpolation doesn't look quite right. To do this, we simply select all the keyframes on the curve that we want to smooth. Go to Edit, Smooth Tangents. And now they're smoothed out. We do the same for all the other distortion parameters we calculated. You can do this for all curves at once by selecting them together and applying smooth tangents. We can see that now the distortion parameters are being interpolated quite accurately. The result of all this work is that when the focus distance value changes, the distortion parameters now automatically adjust as well. This means we can animate or fine-tune the focus distance, and below we'll see the distortion dynamically update accordingly. This also means that when tracking with this distortion preset, we can now use adjust for the focus distance parameter. Go into the adjustment window and fit this value to the specific shot. We can also save all of this as a lens preset. If we have many shots captured using this exact camera and lens combination, there's no point in rebuilding the preset from scratch for every new project. We simply save this lens with all of its animated keyframes, and later we can easily load it into a new, even completely empty project and use it right away. Let's give it a name. Right-click on the lens, Export Lens. Choose the location where you want to save it. Okay, lens exported. Even if we create a completely new project and load in a new plate, we can immediately import the saved lens. To do this, right-click in the lens list, select Import Lens, and locate the file we saved earlier. Choose whether to create a new lens or replace the current one. Let's replace the current one. Okay. And here it is. All the keyframes are already imported. That's how dynamic distortion presets are created in 3DEqualizer.